welcome aboard for our science lesson today. It's Tuesday, so it is our science day. I have put our Nearpod in the chat, and it's time for our teacher helper. Go, Mackenzie.
Participate, be respectful, on time, microphones muted, include full name in Zoom window, stay seated, eyes on me.
Wow, that was great. You even remembered Zoom window. I always forget it. By the way, you're the best class ever. Yay! Truly, truly, I mean it. You're the best class ever. So thank you for being with me. Let's move on to what is today, Mackenzie?
Sorry, I tried to find
okay.
my button. Today is Tuesday, February 7th, 2023.
Wow, fabulous. And keeping in mind that we do not have school on the 17th. So plan for that. There are no DBAs or help sessions on Friday the 17th. Okie dokie. Okie dokie. Thank you, Mackenzie. So we're going to move on. By the way, if you're just joining us, we do have the Nearpod in the chat. Zoom chat, that is. Weekly spotlight winners. Ooh, we need a little bit of a drum roll. And here we go. Who did I choose? I've noticed Madison is our awesome Zoom promise keeper. She has been in the lessons and she's been like super quiet. I hope Desiree comes today. We might have to play the game. I hope she joins us so we don't have to do it without her. I'd like to have her here. But anyway, she was the Zoom Promise Keeper last week. So Miss Madison is going to be our Zoom Promise Keeper this week. Isaac, amazingly detailed responses. Whoa, I love your responses because it's so detailed. You include the facts, the information, the references. I love it. So continue what you're doing because I really enjoy reading your responses to your work. Mackenzie, working hard, keeping up with all her assignments. Love it. So many of you are doing the same, so I appreciate you. Once again, best class ever. All right, let's have a little birthday celebration for our friends, Miss Desiree and Miss Madison for the month of February. Yes. Ooh, I'm in March. Shh. Wait, I shouldn't have said that. Be quiet, Miss Cruz. Why this lesson? Why now? What are we doing today? We're going to demonstrate that the greater the force, the greater the change in motion. So what does that mean? That means that the harder you push, maybe the farther it will go. I don't know. Ooh, how about the lighter you pull, the less force you're using, maybe it will have an effect on how far it will go or how fast it will go. So we're going to demonstrate that the greater the force, either a push or a pull, applied to an object, the greater the change in motion of an object. The greater the force, the greater the motion. And then the next steps, you guys are going to start working on magnets soon. If you haven't already, you're going to learn about the force of magnets. Now, guys, look at the screen. I have some ideas for investigating the effects of force. All right, so let's look at number one real quickly. Have you done that at home? You can get a straw and cotton balls or puff balls and see how far they will travel with a light force. If you just blow real lightly. And what if you really blow really hard through that straw? That's a strong or greater force. How far do you think that will go? Look at number two. They have something where they're measuring. Looks like they're measuring the distance. So that's important because when you're collecting data, yeah, you know how you collect all the numbers. Well, measurement is part of data. So you can decide how far something's gone. Then you can compare the data. You can't just guess. I think it went 8 feet. I don't know. If you measure it, you'll have accurate data. Number three, catapult. Look how they taped they taped like spoons to popsicle sticks. And then they put little baby marshmallows, those tiny marshmallows. And then they're going to pull the spoon back. What do you think's going to happen? Woo! That's right. Now, if they only do a slight force, how far will it travel? If they do pull it back really far and give it a great force, I think you can predict what will happen to that marshmallow. Number 4, anybody here play baseball? Raise your hand. Anybody slid into base? Well, if you only just kind of run slowly and do a gentle slide, how far will you go? What if you're running at top speed and then you slide? How far will you go then? So we're looking at the differences between a small force and a great force, okay? Big and small. Number 5, I love paper airplanes. And he even has a rubber band on his. You don't have to do that. But if you can get with your family to make some paper airplanes, if you push it really hard to make it fly, you're using a greater force. What if you just gently push it forward? And what about number 6? Oh, that one looks really cool. So it looks like she has an old empty soap container with air in it, and she's trying to knock down her pyramid. Once again, what do you think a gentle force would do? What do you think a strong force, which you really squeezed it really hard? Okay, guys, that's enough. I just wanted to give you some ideas. Let's see, with your fingers, which one do you want to try? 1, 2, 3, 4, 5, or 6? Show me. You going to try that at home? Awesome. Oh, look, he's going to do the paper airplanes. Nice. All right, let me know how it turns out. Let's Nearpod. Let's do it. I'll meet you over there. I'll put the code in the chat one more time. And I will meet you over in our Nearpod. Let's see how many friends have already joined us to learn more about the effects of force on objects. All right. Can you see my code, guys? Yeah, thank you. Thank you, Leon. Thank you, Addie. All right. So I already have, well, it says 0 friends. Oh, no. Who's coming? Is it slow today? Did anybody else have internet issues yesterday? Yeah, I lost internet. I know Leon's mom and I were talking about it. You too, Addie? Oh, it was terrible. Oh, good. So we're all in. Whew. Much happier now. All right. So we have 8 friends in. Let's do this. Demonstrate that the greater the force, either a push or a pull, if you apply it to an object, then the greater the change of motion. How much do you already know about the effects of force on an object? A, I know a lot about force. I can explain the effects of big and small forces. B, I know a little bit. I need some practice. C, help. I need more instruction and support. Let's see your answers. Ooh. Okay, I have a couple more friends waiting for their responses so I know how and what I need to teach you. Fabulous. Thank you for being honest. I appreciate that. Hi, Isaac. Oh, yep, got Isaac's answer. Hi, Lucian. Hi, Leon. I see you. I see Ava. Hi, Frank. Hi, Addie. Hi, Mackenzie. And hi, Emmy. All right, here we go. Let's have a quick review. You learned this last year. So this is asking you if you remember the definitions for pushes, pulls, and force. See if you can figure it out. Read them carefully. Whoa, Lucian, Emmy, Leon, nice. So fast. Okay, answers are coming in 10, 9, 7, 6, 5, 4, 3, 2, 1. All right, how did you guys do? Here are the answers. What's a push? Who wants to read push for me? Who wants to read? Emmy, go for it. You've got a fast hand. Go. Definition of push.
That moves an object away from something or someone.
Right, push. moves it away. Very nice.
I always have
Excellent,
my
Emmy.
hand up. I love reading.
Thank you. And Pull, who's going to read Pull? Anybody want to read Pull? Pull, Pull, Pull. All right, Emmy, it's all you again. Go for it.
A force that causes an object to move towards something or someone.
Awesome. Pull. To pull it toward someone. So everybody pull. Pull. That's right. Toward you. All right. How about force? Who wants to read force? Ava, look how fast your hand is. Go for it. What's a force?
A push or a pull.
That's right. The definition of force is either a push or a pull. That's right. It's easy. Is that easy? That's easy. Okay. So these were just a quick review. Now that I know that you remember the definitions for force, the two types of force, pushes and pulls, let's watch a quick video. Everybody throw your eyeballs at the screen. Some of you are in motion right now. Mm-hmm. Oh no! What is an earthquake? An earthquake.
I couldn't hear.
Oh no, really? Okay, let me
I
double check.
know, me too. That's why I was raising my hand.
Okay.
Not
Hold
me
on.
either.
Hold on, guys. Let me fix that for us. Gotcha. Okay, so now that you're going to be able to hear it, let's read this sentence. It says an earthquake is an example of a blank force. So now remember earlier we talked about what we're learning today. We're going to learn the effects of both a strong or weak, which we can also call big or small force. Please don't unmute. Uh-oh. Okay, so let's read through the sentence and choose the answer that you selected. Most of you selected big. So guys, an earthquake is an example of a strong or big force. They actually rate the earthquakes. They actually rate the earthquakes. There was recently an earthquake and many people suffered. Yeah, it was really too strong for the buildings and the roads. So they rate them. They show just how strong they are on a scale. Okay, so the ones that are super strong have a really high number, and the ones that are weaker have a smaller number. All right. Can you hear it now? Give me a thumbs up.
Motion is all about force. Force causes motion. A force is either a push or a pull. When a force pushes an object forward, it could make the object move faster or move in a new direction. A force that pulls can make an object move slower or make it stop completely. Gravity is a force that pulls objects towards the Earth. When an object is dropped, it's the force of gravity that causes it to fall. Magnetism is another
Oh, you're going to
kind
learn
of
that
force.
soon.
Magnetism is the property found in magnets. Magnetism can pull or push objects. Isaac Newton was a scientist who observed motion and created 3 laws of motion. Newton's first law of motion tells us that every movement or change of movement is the result of a force. For example, the force of a golf club
watch.
causes the golf ball to roll. And when the ball stops rolling, it is a
Wait, did you guys see that? He just hit the ball. He hit the golf ball. Was that an example of a big or a small force? Ah, why? Anybody want to discuss it? Go ahead, Eva.
It's because when I watched the video, I could see he didn't really hit it hard, and he kind of hit it kind of like in the middle of like slowly, and then that made it like a small force.
That's right. A small force made it move slowly. It's almost like a little tap, right? It was he almost tapped it. Why do you think he didn't hit it really hard?
It's because it maybe will get lost.
Oh, that's true. He might, if he hit it really hard, if he had a big force on it and he smacked that golf ball, where would it have gone? Emmy. Thank you, Ava.
I think he didn't do it so it wouldn't like so a person wouldn't steal it.
Oh,
like if
that's
the
true.
phone proves far, a person would have just picked it up and stole it.
Oh no, then he would lose his game. That's right. Very good, Emmy. Thank you. How about Mackenzie? What do you
He might
think?
have been close to the hole, so he didn't push it very hard so that he could get it in.
Oh, that's a good point. Have you played golf before or putt-putt, miniature golf? Yeah, you know.
Me
So
and
sometimes-
Ava did it in Tennessee.
Oh, awesome. Yeah, you and Ava, that's great. So you understand that maybe he only had to go a short distance. And when you go a short distance, you don't need to hit it really hard. You don't need a big force. Isaac, I'm ready for you. Isaac, did you want to share?
He would try to hit it the hole while playing.
Oh, that's right. In the hole. Yeah, so he can get the points. Exactly. All right, guys, thank you so much. Yeah, I agree, Isaac. Thank you. All right.
it is a force that causes the ball
Yep.
to stop.
Look, he missed it, but there's the hole.
Newton's second law of motion explains that the speed and direction of an object, like this baseball, is determined by the force, how hard the pitcher throws, and the mass of the ball. Newton's third law of motion explains that for every action, the batter hitting the ball, there is a reaction.
Ow.
The ball flies off at a different speed and direction. Like these billiard balls, forces and motion set other forces and motion into action. Motion comes from motion. Every force comes from another force.
Almost done. Watch this.
Now that you better understand motion, think about this. What determines the motion of a bowling ball?
All right, what determines the motion? In other words, what force is being used to move the ball? Think about the two forces. Remember we had a little review? What were the names of the two forces? Yeah. A big what? Big. Oh, Addie says it's a push. Did he push the ball down? Yeah. It was a big force. I agree, Ava. And Mackenzie says a big force. What type of force was it? Do you remember the review where you had to read to match up what the two names of forces are? You could either do this or do this? What is the force that was used to put it in motion? It does go really fast. What did they do to the ball to make it go? Push, says Frank. Did they pull it too, Emmy? They pulled the ball? Which one did they do? Addie says a push. And it was a big force. You can type it in the chat too, if you need to. Oh, you pushed the ball. The force was big. Very nice. That is a nice, complete thought. I like that. Not only was it a push, but it was a strong, a big push. That's right. It was a large force. Big force. Okay, let's move on, guys. Great. But I like having the two details so I understand it was a strong or big force. Ruby wants to go bowling. Hey, Ruby. She's got your name. Ruby wants to go bowling. She wants to explore how big and small forces affect the distance that an object will travel. We'll think about that for a minute. If Ruby needs to knock down the pins, what type of force would she use, and would it be a big or small? So here's your job. Move the bowling ball to a place anywhere on the line. I don't care where you put it. Then choose the label, either big or small, to identify the type of force that you used to get the ball to that distance. Let's see how we're doing. So I'll repeat the directions one more time. Your job is to take the ball and roll it on that line, make it stop anywhere, and then label it. It was your force. Do you think the force was big or small? Oh, just one. Just one. Leon, too many. Okay, let's see. Oh, and you can take the little arrow label and put it right on top of the bowling ball to show or prove that it was either a big force that got it that far or a small force. Okay. So I'm going to try mine. Here we go. You guys ready? I'm Ruby. I'm going to roll it. Ugh. Oh, I didn't get it very far. It's a small force. What do you guys think? Well, what if I did it this way? What if I said, ooh, I must have gone bowling and I gave it a big force. How about that? Does that look good? Did I do it right? What if I got it backwards? What if I said, I only got it this far, but that was a really big force? That wouldn't make sense, would it? No, I agree. Okay, so let's go back and look at yours. Yes, longer distance, shorter distance. And then you have to label it with big force or small force. You can stick it right on top of the bowling ball if you want to. But don't worry, if you didn't, you can practice this again later, okay? So if you didn't follow every single step, you can practice it later. And now we have something new. This is helping us understand that we can do degrees of force. Now, here's what you're going to do here. This is super easy, guys, just super easy. Circle or put a stamp on the labels and or pictures that demonstrate what would happen if we applied a big force. So it is right under the red box. It says, this is a big force. Think about what the results of a big force would be, and circle the words and any pictures that would match the effects of a big force. And let's read through the words. Okay, so let's see. Big force, big force. Does it affect the speed? Yeah, it moves faster, man. If I really push something hard or pull something hard, it moves fast, doesn't it? Or does it? Would it go shorter distance or longer distance if I used a big force? Shorter distance, longer distance, circle the one. Or would it move slower? What would the results of a big force be? And then you can look around at the pictures too and see if many of them, all of them, some of them represent the effects of a big force. Okay, let's go back and see. Okay. So are you Xing those out, Abby? Oh, I see it. I see it. Okay. A big force, she says, she put an X on move slower. She understands that it would move faster. The object would move faster, right? Yeah. Oh, very nice, Addie. I see it. Frank, I agree. Longer distance moves faster. Yep. Oh, there's Leon. Leon, does it move slower or faster? Choose only one answer for a big, think about a big push. If you really pushed, I don't know, a shopping cart really hard, big push, would it go fast or slow? Circle one of them. Oh, okay, then maybe cross out slower, right? Cross that one out. And would it go a longer distance or a slower distance? Sorry, shorter distance. Let's look at Ava's for a second. Ava, you've circled slower, faster, shorter, longer. If you took a shopping cart and you pushed it really hard, would it move fast or slow? Would-
It would move fast.
Okay. Do you want to cross out slower then?
Yeah.
Okay. What about longer or shorter distance? If you pushed a shopping cart really hard, big force, would it go a long distance or would it only go a short distance away?
It would go a long distance.
Do you want to cross out shorter distance?
Yeah.
Okay. All right, guys, you're learning. I love it. All right, now, Frank, talk to me about why you circled the little student playing or the little athlete playing soccer. Does she, how does she show a big force? Tell me what she's doing.
She's kicking really hard.
You can tell that that's going to be a strong force. It is because she's running to do it and her foot is back really far. She's going to kick it with a big force, isn't she? Do you think that ball will travel a long distance or a short distance?
It would go right in the net. I would say a long distance.
You are right. I love the way you circled that. Great job, Frank. Addie, let's pick Addie. Addie, let's look at the baseball player. Talk to me about why you think that was an example of a big force.
Because he's pulling back hard.
Okay, pulling back the bat.
Yeah. And then he's
Ah.
going to. I used to play baseball.
Does he push the ball or does he pull the ball?
Push.
Yeah, very good. And that is an example of a strong or big force. Thank you so much. All right, guys, let's move on. Now I think you're pretty clear on the big force, the effects of what would happen to an object with a big force. What do you think we're going to do next? Small force. Okay. Circle or stamp the labels and pictures that demonstrate what would happen with a small force. Gentle push. A slight pull. Ah, very good, Miss Emmy. It would go, what did you say? A shorter distance and it would move more Did you write slow? Yeah, she wrote slowly. That's right. Yeah, it's very good. Think about the golf ball. And if you only tap it just very gently, it doesn't go very far. The distance is short. Nice. Oh, yeah, this was awesome, guys. Very good. Isaac, does it move slower or fast? Oh, he's working on it. Nice. Lucian, I agree. It does move slower. Yeah. We're going to talk about examples in 2 seconds. 1, 0. Great. I think a small gentle force will only cause the object to move a shorter distance, and it will move much more slowly. And I'm going to circle my little friend, the toddler playing bowling. And I'm going to pretend that he just gave it a gentle push because he's not strong enough to push hard. All right, love bugs, let's go on to the next part. Let's investigate. Ooh, this is really cool. It's like an experiment online. We will demonstrate the effects of a big and small force on a swing, also known as a pendulum. Pendulum. Have you ever been on a swing set? Raise your hand. Yeah. If you are pushed with a small force, do you travel a short distance or a long distance? Ava?
I think you do it with a hard distance.
So if somebody pushed
A
you
big-
really gently, would you go a long distance or just a short distance?
Short distance.
Very good. Thank you, Leon. Thank you, Ava. If you're pushed with a big force, you're on a swing set and somebody gives you a big push, Leon, what distance do you travel? Short or a long distance?
Long distance.
Yes, I agree. Nice work, Mr. Leon. How does the force of a push affect the speed? Do you go faster with a big push or a small push? And what else do we observe? Let's do it. Okay, guys, we're going on a swing set. Sort of. That's you. You're number 1. Okay, and now what you can do is I can give it a gentle push. Well, okay. Maybe you're only like a year old. You don't want to go screaming through the sky, do you? Maybe you want mom just to give you a gentle push, but you're a little bit older now, right? So should we give you a bigger push? I'm going to pull it back a little bit, but then I'm going to push it forward. Go, guys. Have some fun. Yeah, Emmy's already trying it. What if I pushed it or gave it a big push? Ready?
I did that and I can't even catch it. It went so crazy.
Does it go faster too?
Yeah.
Yes. And does it go a longer distance?
Yes.
Yes, it's great. Awesome job, guys. So when you get the self-paced version of the Nearpod, you can practice this at home. It's a lot of fun. You can also practice it in real life, but be careful. I don't want anybody falling off swing sets. Okay, here we go. Big and small force. Okay. We're almost done. We're like 4 or so slides away. Now, your job, your time to shine. Here we go. What everyday objects? Look around your house, look in your garage, look in your backyard, and then come back and tell me what objects use a small force. Now, when you list this, you have to choose. I don't know if you can see my screen. You have 3 choices. Okay, so you're going to give your answer and then tell me which object would you use a small force on, which object you then click big force, and then if you want to explain why, you have to click on explain why. So for an example, I was thinking about the forces that I use, and when I open my refrigerator door, I don't swing it open with a really big force. I don't want to break my arm or crash anything. So for my refrigerator, I'm going to refrigerator. I can't spell it. And then I'm going to make sure that it says small force in my menu. And then I'm going to click send. And that will put that in my small force column. Now I'm going to think about an object that I use a big force on. Oh, a really big force. Do you know what I have to really, I was thinking about it when I have to use a big force, it's to push my vacuum. So when I really want to push my vacuum, I use a big force. So I'm going to type vacuum, and then I'm going to come over here and select big force as my example, and it will go under that column.
Do
So look,
you see my answers? Because I don't really know how to do it.
I was just explaining. Can you look again? I'll do it one more time. Are you ready? All right.
Okay.
So look at my screen. First, you type your response. Think about an object that you use or that uses a small force. Think about the small force first. So when I pet my dog, I use a small force, but I have to come over here. Look, look, look. It says big force. Now I'm not going to use a big force to pet my dog. He'll lose all his hair. So I'm going to select small force and then click the arrow, and it will go under the small force.
Okay.
You got it? And then you can choose a big force. So let's look at some answers. Oh, yes, that's great. A little game. You might use a small force for a game. When I open my refrigerator, I use a small force. The drawers on your desk, that's right. Use a small force. You gently pull them out. Yes, a small force can make things move slowly. That's right. Emily, oh, Emily, did I say Emily? Emiliana, she uses a little force when she's pushing a little child on a swing. Very good. You don't want to make them fly off and get hurt. When I pet my dog, I use a small force. Lucian uses a small force when he's playing golf. He wants to make sure that he doesn't go past the hole. Oh, Isaac, you can try that again. Is that a big force or a small force? If you want it in the big force column, you have to select big force. I like your picture though. Okay, let's look at our big force answers. When I push my vacuum. Oh, when you ride your bike, Addie. I didn't think about that. You have to push the pedals really hard, don't you? Yeah, nice. All right, you can continue this on your own. Now it is time to finish and wrap up because it is how does force affect speed and distance? Drag the cars onto the lines in front of Miss Ruby and Mr. Jacob to demonstrate the effects of a big force for Ruby and a small force for Jacob. They're already labeled, so don't mess them up, right? We already have labels. So show how far the car would go with a big force. How far the car will go with a small force. And then drag the words into the table to show how fast or slow the speed of the object will go. Can you do it? Can you do it? Can you do it? Yeah, you can. Let's see. Oh, I can't see the answers yet. All right, so I'm going to give her the purple car. Big force. Small force. Which one was slow? Small force. Which one was fast? Big force. Done. Can you do it? Can't see any answers. Did you get it, guys? Addie, did you get it?
Yeah, tell her you sent.
Okay. All right, wrapping it up. Oh,
I
Frank.
got it.
Good, good. Don't unmute. Frank, did you get it? Awesome. Frank, does your table show that the big force will have a fast speed and the small force will have a slow speed? Yeah, that's wonderful. You got it right. Emmy, do you show that in your table, the speed of the object will be fast for a big force and slow. Yeah, you got it, for a small force. Excellent. All right, guys, you ready to wrap it up? Let's go to a time to climb. If you need to go, you can. We're wrapping it up, but we're at the very end, okay? Time to climb is thinking about it. Choose your player. I'm gonna go ahead and race through. How about space? Mackenzie, is space okay or sports? Space or sports? Quick.
Space.
Let's do it. Let's do it. Okay, choose your player, guys. This is just I think 8 questions. Then we have our final poll and we're free to go. This is going to ask you some questions about types of force, pushes and pulls, the strength of the force, big or small, the effects of force. Oh, we're pretty much in. 7 players already. Okay, let's do it. You can join at any time. 3, 2, 1. First question. Is this a push or a pull? Are they pushing or pulling? A is push, B is pull. That was a pull. Okay, how about number 2? Let's see if we get this one. Push or pull? What are those kids doing? A is push, B is pull. Those are pulling. Oh, have you ever tried that? That's a fun game. Tug of rope. Push or pull? A, is he pushing the rock, or B, is he pulling it? Yes. Ooh, everybody got that one? Almost. Awesome. Okay. Question number 4. Is he pushing or pulling the cart? A is push, B is pull. Push or pull? Yep. If you said push, he's pushing it. Yeah, thankfully it's on wheels. How about push or pull? What's the dog doing? Pushing or pulling? Does your dog do this? Yeah. Yes, he's pulling. He's pulling the poor person. Must be excited about a squirrel. Should they use a big or small force to sink the golf ball into the hole? This is just like what you guys were saying. You played up in Gatlinburg, and it's a small force, just a gentle tap. That will get it into the hole. Very nice. Frank, I'm not getting your answers. I don't know why. It's okay. You can always type it in the chat. All right, he wants to hammer that nail in. Should they use the big or small force to hammer the nail in the wood? We have 2 people that haven't answered. 1 person who hasn't answered. Oh, well, it was a big push. Big. You got to really smack that in there. It's a hard, strong force. What type of force is being used to move the roller coaster? Oh, Frank, you froze. A, big, or B, small? Big. Yes. You need a lot of force to move all those cars and people up the ramp. Yeah, very good. What type of force are they using to knit a sweater? Aw, I wish I learned how to knit. Is it small or big force? Think about small as being gentle and big being really strong. If you said small, yeah, you just do a gentle force to make a nice little sweater. It's very soft and gentle. Okay, how'd we do? Ooh, very nice. Good work, guys. Love those scores. Now, following today's lesson, how much do you now know? Have you learned anything more about the effects of force on objects? A, I know a lot. I can explain it now, the effects of big and small forces. I understand about strong or big and small forces being strong or gentle, and how a strong force will move it farther and faster, and a small or gentle force will not move it as much, might be a shorter distance and slower. B, I know a little bit. I need some practice. C, help. I need more instruction and support, which is totally fine. If you answer it honestly, I know what to work on, and so do you. Oops, I didn't see the answers. Go back. Thank you. Ooh, more people in the A. I appreciate that. And if you're more curious about it, let me know. We will also do some more work in the future. Thank you for learning with me. We're all free to go. You guys did amazing. Thank you for your help today. You helped me a lot.